And we'll record from the current slide. Okay. Yes.
When you record these different lessons, how do we pull them up if we want to review them?
Okay. You know how to get to Blackboard, right?
Yes.
This class in Blackboard.
Mm-hmm.
Okay. Somewhere on the front, the home page of Blackboard in the upper left, at least for me, like the second or third tab there in that block, it says Content. Content.
Yes, sir.
When you click on that, you'll see a huge thing come up, and there will be the syllabus, the my locator card when I'm on campus, when I'm not, when I'm in class, when I'm not in class. All the PowerPoints that we've done, or that we will have or will be doing. And then I think the very next thing will be, it says MTH098 YouTube videos. If you click on that, you'll be able to see all the ones we've had. All right. Has anyone looked at it? Did that?
Check.
Huh?
I said I'm about to check.
Okay. Is it there?
Blackboard's getting slow.
Oh, I see. That's not surprising. Over the weekend, I was trying to get some emails caught up because I was out so much last week. And everything I went to our homepage for, it just was so stinking slow. Other things were not too bad, so I think that maybe the system servers, I don't know, have some problems. Okay, let me just brief you. I don't know if y'all noticed or not. You probably did. I was sort of having it rough last week. And I think I told you part of the reason why, but I found out more detail this time. It was because Greg Joy showed up. No, I'm sorry, that's not it. Okay.
That's right.
What's that?
That's right.
Okay. And I already got Ryan here. I was hoping he was coming back, so he made it. Not last Thursday, but the Thursday before, I started a new treatment for the leukemia, and they did a 10% dose on that Thursday just to see if I could handle it, because it sometimes causes pretty violent reactions. I had no problem with it, and then I had the 90% of it on Friday then. No problem then either. But then last week, I was just totally fatigued, and I was hoping it's because the stuff was working, and it was. I mean, it worked big time. My counts before that Thursday treatment were 128,000 white blood cells, okay? It's supposed to be between 7,000 and 11,000. So 128,000, more than 10 times the number of white blood cells it's supposed to have. But they have been crawling upward because the last treatment wasn't doing all that effective of a job. So when I went in Friday of last week to do the second round, they said, well, get blood work done just so we can see how effective, if it was effective, but it's not going to change your treatment. We're going to treat you anyway. So went in, had the blood work, and then they set me up and started the treatment, and then the blood work came in, 1.1 thousand, from 128,000 to just over 1,000, way below what my range is supposed to be, 7 to 11. So it was extraordinarily effective. But on the other hand, it also knocked my red blood cells, my hemoglobin, and my hematocrits down. Not nearly as far down as the white cells, but it knocked them down too. And then my platelets, I mean, it really did a number on them. But that was why I was so out of energy last week. And since they already were doing the treatment, they couldn't stop it. They went on and continued that. And they said, I was supposed to have treatment again this Friday. They said, go in for blood work, which I wasn't supposed to have, but do not let them do anything to you until the doctor sees the blood work. The odds are I'm not going to have a treatment this week at all, because we'll see. But I'm also pretty tired today. It started not nearly as bad as I was either Monday or Wednesday of last week. But it's what's that?
It's not under the content. I can't find it.
Okay.
Video.
You got this class.
You have the locator card and all the things, but there's no. This is the content card. And then when you go to chapter,
Oh, wait.
it's a whole different thing. This is
Yeah.
yours.
Okay, may be for some reason. Now that you say that, let me, sorry to take class time doing this, but let me, Paul, I should have gotten PowerPoint open before I did that. There it is, and we'll go from current slide. All right. Now, before we get going here, let me go over a couple of things. Number one, last time y'all said you wanted the test on Chapter 10 next time, so Wednesday we'll have that. If you do have problems, questions, anything else that comes up before then, remember what my office hours are. And as I was saying before, maybe go over this too. The way I'm feeling right now, as soon as class is over with, I can take care of a few things, I may be heading home because I'm pretty much burned out from the day. I was telling the others my treatments were extraordinarily effective that first week, probably just so last Friday as well, but it has my red blood cell count, hemoglobin, and hematocrits look, not super low, but look, platelets very low, and the white blood cells very, very low, which is what it was designed to do. So I'm just not, I don't have a lot of energy. So I think I'll be going home shortly after class is over with, unless I really feel better after class. I might. So, but catch me tomorrow. I've got an 8 o'clock class and a 9:30 class, and I'm going to try to stay here as far into the afternoon as I can. Normally I'm here till 5:15 at least, but if I run out of juice tomorrow, I'll leave early tomorrow. Now, most of the time on Monday and Wednesday, I'm here at 7:45. This morning and most of last week, I just stayed home, slept a little longer, just so I could have a little more energy during the day. So I may not be here until close to 9:30. Today I was more like 8:45 to 9 o'clock, but that's probably about what time I'll get here on Wednesday. But after my 9:30 class, which ends at 11:10 because it's a 4-hour calculus class, I'll be available from 11:15 until this class starts at 2. So that's going to be the best time to get me. You might be able to catch me some of the other times, but that's going to be the best time. If you have any questions before the test, please see me during those times. Okay. Also, several of you did turn in the first quiz, and one person turned in the second quiz. If you're still working on the quiz, I want you to work on them, but I can't return them to you until I get everybody's in. You can come see the score right after class if you want to, for those who turned them in last time. See what you missed, but I can't return them to you because there's still papers out. Now, if at 2 o'clock on Wednesday you haven't turned in the quiz, you'll need to finish working on the quizzes before you can take the test. That's the reason I give you the quizzes, so you can know what kind of material to be looking for. Then you'll have to make up the test during my office hours, whenever we can work that out. But so try to get the quizzes in before 2 o'clock on Wednesday. Sooner rather than later. The sooner I have them in, then I can get them back to you. So get those in as soon as you can. All right, any questions? Okay. Now, where we left off last time, we had done example 2 in the text and on the slideshow. And Tiana? Okay. I see you are here somewhere. Okay. Okay, anyone else come in since I called wrong? Okay. We're in 11.2, and we finished example 2, both the one on the slide set and the one in the text. Okay? Any questions on that before we proceed with example 3?
Sorry, what page?
This is on page 741, near the bottom of the page. Okay? Now, I'm guessing they don't do example 3. I can't remember. No, they skipped example 3. So what I'm going to do is do example 3 on this page, and then we'll do it. So here's example 3. Any questions before I get started? Okay. It's graph this. Oh, let me get my pen set up. Sorry, the old gray cells aren't working too well this afternoon. Sorry. Y is equal to negative 3 halves x plus 3. Okay? It says graph that. Okay. Now, what would be your procedure for graphing that equation? First off, do you know what kind of graph it's going to turn out being? Straight line, exactly. I hope that's what it meant. Okay. Because the exponents are 1 and 1. Okay. So it's going to be a straight line. Which way might it be heading? Anyone hazard a guess there? Left. Okay. Okay. Most of the time we talk about it going from left to right. When I say which direction, is it going uphill or downhill left to right? Okay, this is going downhill left to right. Why? Because what? Okay, the slope is negative. Okay? Where would be a good starting point for that graph? Say again? Okay. That is a slope where you really need a point before you can use the slope. Positive 3. What is that positive 3? The what? Y-intercept. Excellent. Okay. So if we're going to graph this, we'll set up our graph here, and let's just tick off a few points here. That means you make them mad. Okay. All right. And we'll do a few up, and we'll do a few down. Oop, I didn't scale them very nicely. So it's not going to look like a nice straight line, but it will be. So how do I plot that first point? Okay, don't go right or left, so 0 for the x, and go up 3. Okay, just don't say yours. Okay, now, that gives us your first point. Where do we go from there? All right, what the slope tells you, rise over run, well, that's a fall, isn't it? Down 3, so it's not a rise, it's a fall. Down 3 for every 2 to the right, okay? Because you usually go left to right. So you go down 3, 2 to the right. Down 3, 2 to the right. Down 3, we can't go, we'll be okay there. But you could have done it the other way. You could have gone up 3, but 2 to the left. The minus has to be with one of them. So up 3, 2 to the left would have been up 1, 2, 3, and 2 to the left here, up there. So there's approximately our straight line, okay? By definition, that's a straight line, okay? Now, that was using just the y-intercept and the slope, which I love the slope-intercept form. Gives you the most information in the least amount of space, and it's easiest to graph. Okay? How could I check this just to make sure? We know that 0, 3 is going to be on that. That's our y-intercept. What other intercept might we use? X-intercept. What's going to be true about that? X-intercept. Okay, what was true about the y-intercept? X was 0. So what might be true about the x-intercept? Y is 0. So let's deal with that. Let's say 0 is equal to minus 3 halves x plus 3. Ooh, ugly 3. Okay. What will you do to solve that for x? Add 3 to both sides. Would you? Oh, subtract 3 from both sides, okay? And that would give us negative 3 is equal to negative 3 halves x. That adds to 0, right? And now what? Say again? Okay, another way of saying that, I'm a little lazier than that. I want to multiply by negative 2/3. That does the same thing, doesn't it? Okay, so let's multiply this by a negative 2/3. Okay, here the minuses go out, the 2's go out, and the 3's go out. That leaves you just the x, what we want. Over here, what do we have? Besides alpha. Okay. Say that again. Okay, yeah, multiplied by negative 2/3. He said we could have divided by negative 3/2, but dividing by something is the same as inverting and multiplying. So I just found it easier to do it that way. I'm pretty lazy. If you want to work harder, you can do it by dividing. Yeah, but does that make sense to you? Isn't dividing fractions invert and multiply? Okay. Okay, let's go back and review that. That was, where was our equation? There it was. We had negative 3 is equal to negative 3/2 x, right? Okay, now the first suggestion, I probably should have followed it, was divide both sides by negative 3/2, right? Okay, do you agree that this becomes 1, right? Negative 3/2 divided by negative 3/2 is 1. Same thing divided. Okay, so that's your 1. So what we have here, x is equal to negative 3 divided by negative 3/2. Okay, how you do a division of fractions, you rewrite this as x is equal to negative 3 divided by a negative 3/2. Remember that? That's just another way of writing a division. You can either write it vertically or horizontally, right? Those are the same forms, right? Okay, how do you divide fractional forms? Minus 3, change the division to a multiplication, but flip it. You remember that? Okay, so that's a negative 2/3, which is exactly what we did there, multiplied by negative 2/3. So let's do it here, and what does that give us? X is equal to, well, the negatives, negative times negative is positive, right? The 3's divide away, and what do you have? 2. X equal 2. Ding, ding, ding. There is where your x-intercept is, at 2, 0. So we already had it on there. I was hoping someone was going to notice that, but that just confirms, yes, we have done it correctly. We got our y-intercept, we got our x-intercept. Does that make sense? No? Okay. Ask a question. Let me see if I can clarify something. Do another one? Another point or another problem? Another problem? Okay, we will be doing another problem, but any questions on that before we move on?
Can we do another point?
Oh, another point. I'm sorry, I thought you said problem. Okay, you give me, what's the point? No, give me an x. I don't care what x. Because we know our formula is y is equal to negative 3/2. Give me an x, any x. Second? 6, okay? Plus 3, okay? Don't think we're going to be off scale, but I'm okay with it if you are. What would that be? Negative? Second? Okay. 2 will go into 6 3 times. Minus 3 times 3 is negative 9, right? Plus 3, right? And that would be negative 6. So when ordered pair, when x equals 6, y is equal to negative 6. Okay? Now, I can't show you on this graph because I didn't expand it. 1, 2, 3, 4, 5, 6. And that would go down 1, 2, 3, 4, 5, 6. Yeah, it looks like it's heading that direction. I think that would be a point.
So we were planting 6 across.
6 to the right, because you chose that as being my x.
Yes.
And you calculated the y to be negative 6. So then you go 6 down beneath that positive 6 there. And sure enough, that looks like it's going strike somewhere down here.
That's the same problem, right?
What's that?
That's the same problem, right?
Same problem, yeah. It's still on the same line. Every point you'll choose should be on that line. If you get a point over here, check your math because you did something wrong. It's got to be on that line. Okay? Does that answer the questions? Okay. All right. Now, that was example 3. Let's see. I think they do show example 4, so let's proceed with example 4. All right, here's example 4. This is, and by the way, if you have your book on page 742, you'll see the graph looks very, oh, not that one. Fairly similar to that. 0, 3, 2, 0, negative 2, 6, and it didn't show this one, but 3, negative 3. That was another point on there. They didn't show it on theirs. Okay. All right, so let's do example 4. Now let's see. Nope. Different one from the one in the book. Let's do the one. Y'all have a preference? You want to do the one in the slide set first and then the one in the book, or book first and slide set? I don't care. Say again? I can't hear. This one first, okay? Graph the linear equation negative 6x plus 2y is equal to 0. Okay? How would you begin? Okay, what's going to be true about the y-intercept? X is going to be 0. So let's plug in a 0 here. It'll be minus 6 times 0 plus 2 times y is equal to 0. This should give you the y value for the y-intercept, okay, because that's where x is 0. That's a 0 plus 2y is equal to 0. Now what? Second? Okay, yeah, that just goes away. Divide by 2, and what does that give you? Y is equal to 0. Uh-oh. Okay? Now, let me just warn you on this. Anytime you have a linear equation with exponents for 1, right, that this is ax plus by is equal to 0, that is guaranteed to go through the origin. No way around it. Okay? Now, the bad news on that, the good news, you know what both intercepts are. But the bad news, you know what both intercepts are. It's the same point, 0, 0. So now you have to pick a couple of more points to make sure you got something that's right. You can't do a separate, you can put a 0 for y, and you still get x equals 0. 0, 0 is both intercepts. So, with that in mind, all right for me to erase this because it's right where I'm going to draw the graph. Okay? Okay, let's clear that off the screen and draw the graph here. Okay? 1, 2, 3, 4, 5, 6, 7. We don't need that many. Negative 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4. Positive 1, 2, 3, 4, 5, 6. Okay. So we know 0, 0 is both the x-intercept and the y-intercept. How many lines can we go through that point? Infinite number. Okay. You got to have at least 2 points before you know where the line is. Good idea to do 3, but 1 point will never, ever, well, back that up. If you know a point in the slope, you could get it. But just a single point is not going to give you the graph of the line. So what might we choose to do? We've already tried both intercepts. It's the same point, 0, 0. And there's several things you can do. You tell me what you would like to do. Say again?
Choose random number.
I can't hear it.
Choose random number.
Okay. All right. You want to choose an X or choose a Y? I don't care. X, okay? Give me an X.
6.
Say again?
6.
6. Okay, y'all like big numbers, don't you? All right, let's plug that in. Minus 6 times 6 plus 2y is equal to 0. Now what? That's a negative 36 plus 2y is equal to 0. Add 36 to both sides, and that gives us 2y, 36, y is equal to 18. I know you like big numbers, don't you? Y is equal to 18. Huge number. So when x is 6, 1, 2, 3, 4, 5, 6, that's somewhere way, way, way high. Okay? So give me a little bit smaller number. Huh? 5. You still like big numbers, don't you? All right, so when x is equal to 5, and by the way, 6, 18. If you drew the graph big enough, you'll find this on there. All right, let's do 5. Minus 6 times 5 plus 2y is equal to 0. So what will we do next? Okay, let me get this out of the way so I can read my writing a little better. Okay, so that's negative 30 plus 2y equals 0. Add 30 to both sides. 2y equal 30. Y is equal to 15. Why not? Okay. You still are way off scale. Y is equal to 15. I like that a lot better. So 5, 15. Okay. So let's do y is equal to 1. Y is equal to 1 or x equal 1? You choose. Y. Okay, why not? Okay. I'm not going to like it so much. Let me erase a lot of this so that we can start over with something we can see. Okay, on our graph. Whoops, I just lost a point there, didn't I? A tick mark anyway. Okay. And you wanted y equal 1? Yeah, we'll do it. I know why you wanted 1. Okay, I remember. So y is equal to 1. So minus 6x plus 2 times 1 is equal to 0. So this time on our table here, we're choosing the y, 1, and we're going to find the x. So what do we do first? Negative 6x plus 2 equals 0. Second? Subtract 2 from both sides, and that gives us negative 6x is equal to negative 2, and then what? Negative 6, and that gives us 1/3. I knew you loved your fractions, and that's why you gave me that one. Okay, so that's why I didn't gripe too much. Okay, 1/3, not 1/2. Okay, now. So what we do now, we go 1/3 to the right and up 1. There's our A point besides that. Let's do another, because that's sort of a fractional form. And though some people love their fractions, I don't care for them that much. But, okay, what would we do? Give me another, either x or y. Second?
3.
Which is?
X.
X, 3 for x. Okay, I think I like that one a lot better. Okay, so it'll be minus 6 times 3. This is going to be a 3 here. Plus 2y. I can't find my equation here. There it is. Plus 2y is equal to 0. Negative 18 plus 2y, 0. Add 18 to both sides, and that gives us 2y equal 18. Divide by 2, and that gives you y is equal to 9. Okay? Still not on the scale, but when x equal 3, y is way up there about 9.
You complain about my fraction, but it's on there.
Okay. All right.
Gave you one that was on there.
All right. Good. Can you give me one a little bit closer on there?
2.
Let's try negative 2. X equal negative 2? Oh, this was 9 here. So x equal negative 2. Okay, we'll do it. Minus 6x plus 2 times negative 2 is equal to 0. What will that give us? Negative 6x. Wait. I'm sorry. You said x, didn't you? And I'm writing y. Okay. Sorry about that. Whoops, wrong one. Okay. Negative 6 times a negative 2 plus 2y is equal to 0. That would be a plus what? I need what the 6 times negative 2 is. Negative 6 times negative 2. 12 plus 2y is equal to 0. Subtract 12 from both sides, and that gives us 2y is equal to negative 12. Y is equal, whoops. Y is equal to negative 6. Okay, still can't quite show it, but it's getting closer. Do you have any objection to plus or minus 1? I mean, they're small numbers, and you can get them on the scale here. Huh? Negative 1? Want to do it for x? Okay, this was negative 6 here. Okay, you could choose x equal negative 1. Let me erase some because I'm getting all over the board here. Okay. All right. Oh, I think no, I didn't. Okay. Okay. All right, which did you want? X equal negative 1? Is that what you said? Okay. That would be a minus 6 times a negative 1 plus 2y is equal to 0. 6 plus 2y equals 0. Subtract 6 from both sides, and that gives us 2y is equal to negative 6. Divide by 2. Y is equal to negative 3. Ding, 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 ding! When x is negative 1, y is negative 3. Right there. Okay? Another one pretty easy to graph. We already did 0. We already did that one. 1! Let's do 1. Minus 6 times 1 plus 2y is equal to 0. Negative 6 plus 2y is equal to 0. Add 6 to both sides. 2y is equal to 6. Y is equal to 3. Divide both sides by 2. All right. 1, 3. And there it would be right there. So here are our 2 points. I'll tell you what another one is. 2, 6 will work, okay? Because that's on that straight line. You could plug in a 2, you'll see that works as well, okay? Now that's choosing points. Maybe not choosing them very wisely, but choosing points. And if your graph's big enough, you could have plotted all those. But after a while, they get to be sort of a pain in the neck, okay? Did anyone want to suggest maybe another way to do this? Didn't want to? Okay. Let me just show you something though. Remembering what we did on a previous problem, like I think the first one we did here, I'm going to erase some of these. And oh, I didn't erase, did I? Okay. And I'll let you decide if which way you wanted to go with it. I don't know if you recall when I said what was my favorite form. Anyone remember? The what? Slope-intercept form. You remembered. Feel good about it. How did slope-intercept form look? Oh, y is equal to mx plus b. So in other words, how you go here is solve. Whoa, what are you doing here? This is going wacko. Okay. Nope, that's not it. All right, here we are. Okay. If we solve, I think I see what the problem is. It just decided to jump to another device. Okay. Let's solve this equation for y. So what would we do? Add 6x to both sides. And what would that give us? 2y is equal to 6x. Solve for y. Divide by 2. And what would that give us? Okay. Now that's in slope-intercept form. Give me an, okay. I see a slope, the 3. I don't see a y-intercept. What does that imply? Say again? It's the origin, 0, 0. Is it y? The b is 0. Okay. In other words, it's crossing at 0, 0. And then you can do up 3 and right 1. Up 3, right 1. Up 3, right 1. Down 3, left 1. Down 3, left 1. Y'all like to do it the hard way, right? Y'all are hard workers. That's really commendable. But I'm lazy, okay? I like to find the easier way to do it. Generally, if you can, yeah, you can pick points, but sometimes you'll get wacko ones or whatever. But sometimes, if it's especially an easy formula like this, solve for y. Then you have slope-intercept form, and then it's pretty much a piece of cake to do it. If y'all like cake, but I do. Okay. What's that?
It can't always be a couch potato.
Can't always be.
A couch potato.
Oh, okay. Well, I do what I can. Okay. Let me erase this and let's see how they showed it. I bet you they didn't do it that way, but let's see. First, we found the intercepts that x equals 0 and the y is 0. So, sure enough, your y-intercept is 0, 0. Then, they did the x-intercept by setting y to 0, and you get 0, 0 again. Oh, what a surprise, okay? So there's only one intercept, and this is x and y-intercept are both 0, 0, okay? Since x and y-intercepts are the same, the origin, choose a different value for x or y, okay? And, oh, they said let x equal 1. What a clever, nice little number that you can probably plot. Let's see what they got. Negative 6 times 1 plus 2y is 0. Negative 6 plus 2y is 0. Add 6 to both sides. 2y is equal to 6. Divide by 2. Y is equal to 3. It took us a while, but they got there. Okay? So now we have the origin, 1 point. Second point is 1, 3, because we chose x equal 1. Y turned out being 3. And that gave us enough to plot the graph. 0, 0, 1, 3. 1, 3. Okay, and sure enough, we got it. Also, negative 1, negative 3. We found that one too. We actually found a few more there, like our good old 1/3 1. Yeah, we got that one too. Such a great choice, but it worked. Okay, so that's how they did. Again, a fair amount of work. If you solve for y, it really becomes a piece of cake. Okay? It won't always. Sometimes you'll get fractions that way too, but usually they're not too bad to handle. All right. That was example 4 in the text. No, that was 4 on the slide set. You want to do 4 in the text.
What page is that, Mr. Fowler?
That's on 742, bottom half of the page. Okay? So let's back up a bit. All right. Their example 4 is x minus 3y is equal to 0. Okay? X minus 3y equals 0. Anyone want to hazard a guess what your intercept might be? Second? 0, 0. That's the only way you're going to get a 0 here, if both of those are zeros. So you only have one intercept. The x-intercept, the y-intercept, same point. So we know one point on this graph will be x, y, 0, 0. Okay, let's go on and start the graph. Going here, 0, 0. Okay, let me tick off a few points. 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4, 5, 6. Okay. Want to give me another point? Which? I like it. Okay. I was going to suggest this before. We wound up doing it, but I didn't actually say it. If I have my druthers, I think I'd rather pick the value that has the larger coefficient. Negative, larger absolute value of the coefficient. 3. So let's choose y is equal to 1 and see what we get. Second, x minus 3 times 1 equals 0. Now what? X minus 3 equals 0. Add 3 to both sides, and you get x equals 3. Okay? Can I plot that? How? 3 to the right and 1 up. There it is. Okay? You want to choose another one? 3 for x? We just did that. Yeah. Huh? 2 for x? 2 for y. Okay, that won't be too bad, I guess. That will be x minus 3 times 2 is equal to 0. X minus 6 equals 0. Add 6 to both sides, and that gives us x equals 6. So that's out here, 2 for y, something about like that. I'm pretty convinced this is going to go like this. Anyone want to hazard a guess what will go on the left? You do negative numbers? Okay, you could do negative 1. I would, or negative 1 for y. Is that what you're meaning? Yes, let's do negative 1 for y. So that would be x minus 3 times a negative 1 equals 0. And what would that give us? I don't think so. X plus 3 equals 0. Subtract 3 from both sides, and that gives us x equals negative 3. Negative 3, negative 1. Okay? Sure enough, it's right down there. And I bet you negative 6 will give us a negative 2. Okay? So sure enough, there's your straight line. So again?
If you get it in one sub-intercept form, you slip just 3, so it's down.
Right, okay. Yeah. This has a positive slope. When you go up 1, you go right 3, so what will the slope be? Say again? Okay. I'm not understanding. My hearing's bad.
You asked about the opposite direction?
Okay. I was just going to say,
If you go negative,
I was saying when you go up 1, you go right 3, right? Every time. So what we give you as a slope? 3. Really? Rise over run? 1/3. Excellent. That's a slope of 1/3. A slope of 3 is going to be really steep. Slope of 1/3 is going to be very shallow like this. Okay? If you've ever put shingles on a house, you like shallow slopes. I don't like those kind. Okay? In fact, my wife won't let me up there. Okay, yeah. The insurance money's not worth it, you know. Okay. Rise over run. Up 1 for 3 over right.
I was looking at that.
Oh, okay.
That's why.
Okay. Now, I thought I heard someone say before, and I was trying to get you to say it louder, and everybody else got to going. Did someone else make a suggestion of, say again? Solve this for, slope intercept, is that what you're saying? Yes, solve for y. So let's start over there. X minus 3y is equal to 0. What would you do next? Subtract x from both sides, and that gives you negative 3y is equal to negative x. It's not writing. There it goes. Then what? Divide both sides by negative 3, and that gives you y is equal to negative, positive 1/3 x. And that's what we just said. The slope is 1, up 1 to 3 right.
Top equation.
What's that?
I forgot that we didn't do the equation that's on the...
Yeah, we had already done that. Yeah. So there we have y is equal to 1/3 x. Choose an x, 0, 0. I choose 1 to cancel out the 3. 3, 1. 6, 2, or 2, 6, 2. Negative 3, negative 1. Negative 6, negative 2. I'm just lazy that way. Couch potato. Yeah, anytime. Okay. I like potatoes. Okay. Does that make sense? Now, if you look in your book, you'll see their slope, their graph looks very similar to what ours does. Okay? So that was example 4. Any questions before we move on? Okay? All right. So here's the graph, linear equations in the form ax plus by is equal to 0. What can you tell me? Right off the top. As soon as you see this. The what? Okay. Yeah, all lines are infinite. Yeah. Okay. So that's going to be true. But what else is going to be true? 0, 0 is going to be your y x and your y-intercept. You only have one intercept, and that's going through the origin. If this is not 0, you have some other line, y-intercept. If that is 0, it's going to be 0, 0. So the graph of a linear equation, ax plus by, what makes it linear? Both exponents are 1, is equal to 0, where a and b are non-zero real numbers. Okay? It passes through the origin, 0, 0. Every time. Because you can't possibly put any values for x and y in here to give you 0 unless they're both equal to 0. Unless, of course, a and b are both 0, then you don't have very much of an equation at all. So, if you have ax plus by is equal to 0, it's got to be a line through the origin. Now, what slope it has, we have no idea. But it's going to be through the origin. Yes, ma'am. Or is that just putting on the square? Okay. All right. Any questions on that? All right. Here's example 5. We'll do the one from the slideshow first. And then let's just first look at what they're saying here. Graph linear equations of the form y is equal to k or x is equal to k. Anyone going to give me an idea what those are going to look like? Say again? The two will be perpendicular to each other. That is a good insight. But what about just either one of them? Y is equal to k. Describe for me what that's going to be. Say again?
1 equals 1.
You mean k is equal to 1? Okay, if k is equal to 1 and y is equal to 1, there y is equal to 1, there y is equal to 1, there's y equal to 1, there's y. All these values here, y is equal to 1. It's 1 up from the origin, right? So what's true about that linear equation? It's a horizontal line with whatever value k is, that's where it's going to cross the y-axis. And that's the only place it's going to cross the y-axis. And in general, it's not going to even touch the x-axis, unless, of course, k is equal to 0, and then everything touches the x-axis. That would be the horizontal line through the x-axis. So that's going to be a horizontal line. How about x equal k? Vertical line. Give me a k, any k? 4, okay? If x is equal to 4, right there, x equals 4, therefore x equals 4, there, yeah. Therefore, 4, okay, yeah. Everywhere the vertical line, x equals 4. So, when they say graph this, y is equal to -2, how would you do that? Say again? Okay. Okay, what's -2? Down 2. And do what? Horizontal line through y is equal to -2. There it is. Boy, that was tough, wasn't it? Now, here's another thing to notice. This is already in slope-intercept form. What's your slope? 0. That means it's horizontal line. Not going uphill, not going downhill. 0 slope. And the y-intercept? -2. 0, -2 right there. Horizontal line through that. Okay? What's that? I can't hear you. Wait, we've still got 10 more minutes. Oh, okay. Yeah, the homework will be odd number exercises at the end. Plus, everybody, I don't know if you were here to hear at the beginning, y'all had said we're ready for Chapter 10 test on Wednesday, right? Okay, so please, if you have any questions before now and Wednesday, if you can get me your quizzes between now and Wednesday, I'll try to have them graded so you can see them before test time. Okay? I'll let anyone who's turned them in already see them now, but so yeah, and 11.2 do any of the odd number exercises. Okay? All right.
Which page?
What?
1.3 of the odd number.
Okay, that starts on page 476 of 746, 747, 748, 749, 750, 751. So 748 to 751. No, 746 to 751. I can't read numbers today. Okay? Let's do, since we got it here, example 6. All right, let's do, there's example 5 here. Let's do example 5 from the text. Want to do it in a different color? Want to choose a color? Red, okay. All right, there we go. In the text, example 5 is graph y is equal to -4. How would we graph that? Go down 4 and do your horizontal line through there. Got it? Boy, I can handle these. Okay, let's do what I think I'll do, example 5 on the slide set here. The expanded version of that linear equation would be 0 times x plus y is equal to -2. Who would want to do that? Here the y coordinate is unaffected by the value for the x coordinate. Whatever the x value you choose, the y value will be -2. Thus you could plot the point -1, -2, 2, -2, 4, -2, 0, -2, anything. And when you do that, you get those points there, and you can see the extension of that is a horizontal line at y is equal to -2. Everywhere on that line, y is -2. Okay, note that this is a graph of a horizontal line, y-intercept -2, 0, -2. All right, let's do this one. Graph x minus 1 equals 0. How would you graph that one? Add 1 to both sides. You want to go back to dark color. Okay, add 1 to both sides, and what does that give you? X equal 1. How would you graph that one? Second? To the right one, and then you go up and down. There it is. All right. There's x minus 1 equals 0, or x equal positive 1. In the book, they had x minus 3 is equal to 0. And how would you do that one? Add 3 to both sides. Whoops, you want to do this in red too? Or something else? Second?
Same color.
Same color? Okay. All right. Add 3 to both sides, and that gives you x equal 3. So there's 1, 2, 3. There would be your x equal 3. Make sense? So when you have y is equal to k, horizontal line, x equal to k, vertical line. Whatever your value for k is, every y value is that same value for the horizontal lines, and every x value is the same value for the vertical lines. Does that make sense? All right, let me erase these so we can see here. Add 1 to each side, you get x equal 1. That's what we did. X coordinate is unaffected by the y coordinate. So every value for x. 1, -3, 1, 0, 1, 2, 1, 1, 1, 15, 1, 85, 1 pi thirds. It doesn't matter. The x is always 1. They plotted 3 of them on there. You could have done a lot more. There's your vertical line. Make sense? All right. Note that the graph is a vertical line with no y-intercept. The x-intercept, of course, is at 1, 0, because that's where it intercepts the x-axis. Make sense? All right. So to summarize that, top of page 744, horizontal and vertical lines, the graph of the linear equation y is equal to k, where k is any real number, is what kind of line? Say again? Horizontal line. Perfect. I was expecting straight line. All lines are straight lines. Okay? This is a horizontal line. It's a horizontal line with the y-intercept of 0k. Other points are 7k, 14k, minus 3k. Anything k. The y is always k. No x-intercept, because it never crosses the x-axis, unless it happens to be y is equal to 0, and then every point is on the x-axis. So the graph of the linear equation x equal k is going to be what? For k is any real number? Vertical line, okay? And that would be the x value is always k. If that was a plus 7, it would be 7, 0, 7, 7, 3, 7, 5, 7, anything, x equals 7, vertical line, x equals 7. No y-intercept, because it never crosses the y-axis, unless, of course, it's x equals 0, and then every point is on the y-intercept. But we usually don't do this. All right, any questions on those? All right. Here's example 7. Bob has owned and managed Bob's Bagels, not Beagles, but Bagels, for the past 5 years and has kept track of his cost over that time. Based on his figures, Bob has determined that his local monthly costs can be modeled by C is equal to 0.75x plus 2,500, where x is the number of bagels that Bob sells that month. Okay? Use Bob's cost equation to determine if his cost, if he sells 1,000 bagels next month and 4,000 bagels the following month. Okay? So what would you do? Okay, so let me go back to dark color here. The cost is equal to 0.75 times, first we'll put in 1,000 bagels, okay, plus $2,500. Okay, so what will it be as cost? Say that again. Okay. Now I'm going to show you my easy way to do this. If someone doing a calculator, that's fine too. If you got 3 zeros here, move the decimal 3 zeros to the right, right? In other words, you move this decimal 3 places to the left, that one 3 places to the right. That would be 750 plus 2,500. I can't write. And that would be 750 plus 2,500. 33, no. Yeah, you're right. 33.50. Okay, got it. And that would be dollars. Okay? 750 plus 2,500. That's 32.50, isn't it? Okay. Good. Trying to lead me astray, aren't you? Okay. 32.50. Now, the problem is not asking this. Okay? But I'm just going to give you an idea of what's going on here. Okay? This is called the variable cost. And what this tells me, it costs them 75 cents to make each bagel. Okay? $2,500 is what he's paying for rent, insurance, employees, everything else. He's got that as a fixed cost every month. Okay? His variable cost is how much it costs him to make a bagel, 75 cents. I'm guessing he's going to have to charge quite a bit for those to make up for $2,500 he's going to have every month to pay out, whether he makes a single bagel or not. Okay, so it costs him $32.50 this month to do, if he sells 1,000 bagels. And this is a little bizarre. It says the number of bagels sold a month. That's the number of bagels made a month. And hopefully he sold them all. Okay, what if he sold 4,000 bagels? Then his cost, and I'm going to put cost of 4,000 so we'll know what we're talking about, would be equal to what? 0.75 times 4,000 plus 2,500. I can't write. Goodness gracious. Okay? Now, again, I would move the decimal 3 places this way, move that 3 places that way. This is just my lazy way of doing it. And then do 4 times $750. Okay? And 2 times 750 would be 1,500. And double that again, that would be 3,000, right? Plus 2,500. I don't have a calculator, so I'm having to do it in my head. That would be $5,500. That's his cost for selling 4,000 bagels, or making 4,000 bagels. Now, let's see. Let's just make up something. What would you think he should charge for each bagel? $1.60? $1.50? Okay, $1.50. So if you charged $1.50 and sold 1,000 bagels, that would be $1,500. Okay? Well, it cost them $32.50. So he lost money big time if he only sold 1,000 bagels. Now, if he sold 4,000 bagels at $1.50 each, is that what you said? That would be $6,000. Yeah, he made some money that month. Okay? Because it cost him $5,500. He made 6. So he'd better be selling at least 4,000 bagels a month. Otherwise, he's awful close to losing money and probably shutting down business. Okay. So, it cost him 75 cents to make it. You said $1.50 to sell it. He doubled his price, and yet he lost money at only 1,000 bagels because he had all that $2,500 fixed cost. It's not that easy making money in retail, okay? You have all that fixed cost to deal with. Okay. That was our example 7 in the text, in the slide set. Let's just see what we've got here. Let me erase this so you can see what answer they gave. Yeah. Okay. They did $3,250. That's what we got at $4,500. Okay. And then it says, write that information from part A, 2 ordered pairs used on the graph's Bob's cost equation. It was $1,032.50, $4,500, and you had one other point that you probably didn't realize. If you sold 0 bagels, still cost them $2,500. That's your y-intercept there. Yep, there it is. There's his cost equation. His revenue equation, we hope, is going to be higher than that. Now, maybe it won't be as steep or steeper. It's probably going to be steeper. He better, well, he's never going to, if he sells 0 bagels, it's going to be down here. So somewhere here you have the break-even point. You know, it depends on how steep the slope is. That depends on how much he charges per bagel. If he charges $1.50, it's going to be something about like that. It's going to be up here somewhere before he breaks even. Okay? Just a little bit there. All right, we'll start. Note that we did not extend the graph to the left because then you'd have had negative number of bagels. I don't know how to make those. Okay. Now, that was the last slide, but it's not the one that's in the text. So we'll do example 7 next, well, not next time. We're going to have the test next time. But when we come back following 1 week from today on Monday, we'll start with example 7 in the text. Homework exercises here. Let's go over it again. Any of the odds. Do number 1. That's 2 questions. Just fill in the blanks. Number 3. Oh, all these have answers in the back, don't they? Okay. Any of the concept checks, 1 or 2 or both, 3 or 4, okay? Any of the odds 5 through 8, any of the problems 5 through 8, any of the problems 9 through 14, any of the problems 15 to 20, any of the problems 21 to 40, 21 to 40, do number 41, any of the problems 43 to 46, and then do some problems, any of these, 47 or 47 through, 54. And then once we finish that, we'll go on to 11-3. Okay? Good deal. Please get your quizzes into me today if possible, tomorrow if possible, Wednesday before class if at all possible. If not, you'll need to be spending part of your class time doing the quiz and have to make up the test later. Okay? Oh, sure. If you want to come in earlier, I'm out of class at 11:15. So anytime between 11:15 and 2 will be fine.
Tomorrow?
No. No, she was asking me if she could come in on Wednesday. Tomorrow I'll be available after 10:45. I just don't know how long. Depends on how tired I get. Talked about that earlier. You can listen to it on YouTube.
Do you use Scantron or anything?
No, just like the quizzes.
Okay.
I like to be able to see where you're making no mistakes. That's what I really like to see. Or if you don't get it right, I like to be able to figure out where you made your mistake so I can address that. So Scantron only tells me whether you got it right or wrong, not where you missed it.
So Wednesday it's going to be like this and
Okay.
one that we turned in. Is it gonna be-
Okay. Actually, I should have said this before, and I'm still recording, so if anyone goes back and listens, it's going to be very similar to the chapter test at the end of the chapter 10. That was on page 723 and 724. Not going to be exactly like it, but similar to that,
7:23.
to 724. Good deal.
To 7.
24. What I don't like about these, I didn't make them out, they were given to me. That one is pretty good until you get back here, and there you're doing things we didn't do in class.
Right.
We did them, I guess you did them in 090, but that was a while back. So I'm not going to test you on what you did then. I want to test you on what you're doing now.
And I still just kind of really struggle, so I have to really put a lot of thought process. I have to really take about 3 hours, maybe 4 hours to kind of with my mouth to try to remember it and keep it, you know, because I could get scatterbrained or something. So it's really, really difficult.
Okay. Well, what I like to do, because I do have in this class at least one student that needs accommodations, I say, why not give it to everybody? So if you need more time, you can. Most of the time I'm here until 5:15. If you need to take more time, you can. If you have another class right after this one, you can put put not finished on it. I'll grade what you have done at that point, and then you can come back anytime and work on the rest of it. So,
I have my microbiology on the Birmingham campus. So
right after this.
Yes.
Okay.
Well, it's an hour.
Hour, yeah, okay. So you can decide how much time you want to do on this, but leaving time to get there. Yeah.
Thank
And then you can come in the next day, and on Tuesdays and Thursdays, I'm usually available from 10:45 until 5:15, if I can make it that long. You know,
understand.
but yeah.
Well,
but-
congratulations on
Well,
this,
thank
that,
you.
You know, being able to get through that.
Oh yeah.
Your chemo. My niece, she was 3 years old and was diagnosed with childhood Wilms tumor. She's 12 now, so she survived that, thank God. 9-hour surgery and
Oh wow.
a year worth of chemo at 3 when she was doing all this. So yeah, I could just remember how tired and just, you know, it was tough.
Yeah.
It was tough. So you do not, I mean, you don't show it, Mr. Fowler. You here, you teaching us, and you know, we just know through you telling us what you're going through, but we're not able to see it. You're not showing it per se.
Well, y'all fire me up. You give me energy. I tell you, if I'm sitting in the office grading papers, I start losing energy really fast. But in here working with y'all, I like your enthusiasm and your questions and stuff. And I'm so glad you asked that, because I thought I had put that out there, but evidently I didn't have the link yet when I did the rest of them, and I had to wait, and then I forgot to go back and do it. So yeah.
That gives me a little bit more to work with, because it just takes me so much time to grasp.
Right.
That's been my problem with math. It's like, oh God, I just wanted to be done already with my math, and there's only really one that we have to take in nursing, so I had to kind of build myself up. It's been hard.
Yeah. Well, I think you're putting in the effort, so I think you'll do it.
Thank you.
All righty.
I'll see you Wednesday.
Okay. Good deal.